Inscribed angles are half of their arc. So let's look at number 1. It wants to know the measure of angle WXY. WXY is W to X, X to Y. That's the angle. Z is just the center of the circle. That doesn't have anything to do with our angle. So we're looking for this red angle. All right, that's angle WXY. So its angle measurement is this right here. How you find it is you find its arc. So its arc is the arc measure, not length, the arc measure is on the edge of the circle. So it's 62. The math is the angle is half of its arc. So if its arc is 62, its angle is half of that. So all you do is cut the 62 in half, and we have 31. That one's done. The angle is smaller than the arc. The arc is bigger. So when we look at number 2, now we have to work in reverse order what we just did. So this wants arc DGF. So we started D. We're going to go through G, end at F. So now we're looking for an arc. The angle that is associated with that arc is what angle meets it at its endpoints. So this angle has those same endpoints, F and D. So that's its associated angle, and that's inscribed. The arc is double the size of the angle. So now we're in reverse order. If it gave us the arc, we divided it by 2 to find the angle. If we have the angle and we need to find the arc, we double it. So one version is to divide by 2, the other version is to multiply by 2. So this is 226, 113 times 2. The arc is bigger than the angle. All right, number 3. Let me erase all this stuff out of my way. Trying to get the whoops. All right, number 3. So we want PQR. Angle PQR. So let me outline that in red. So we want this angle right here. That would be this guy. That's what we want. So let's look at its endpoints. Its endpoints are P and R. Okay, there's an arc that goes with that. Here's the arc that has those same endpoints. Now also, first time we see this, anytime you have a diameter, you got to pay attention to that. So this is on a diameter. That means that right there is a half circle. So any angle that has endpoints on a diameter. So the diameter P to R, and this angle is on that. This is always going to be a 90-degree angle. Its arc is 180. The inscribed angle is half of that. So that means if its arc, the blue arc is 180, that means this has to be half. Any angle whose endpoints are a diameter is always a 90-degree angle. That's where this P line, this pink line comes in. That works every time. You'll definitely see that again. Number 4. All right, we want arc B to C, so we're looking for this one. So here is our first question that wants an arc that's not associated with the angle it gives us. This arc isn't even associated with any angle. So how do we find this when you're given a problem like this? Well, always pay attention to your diameters, because that creates half circles. So arc ACB is 180. That's a half circle. And I can find this portion here. I can find A to C, because I know that arc is associated with this inscribed angle, and it's going to be at double the relationship. So this is 94. This red arc is double this inscribed angle. And anytime you see a diameter, that's definitely telling you half circle is 180. So that means this arc is going to be 180 minus 94. So 180 minus 94, 86. The arc we need is 86. So they give you diameters for a reason. Everybody okay and ready to go to number 5? I'm trying not to go too fast. I might be going to. Please speak up if you need me to slow down. I'm fine with slowing down. I'm perfectly happy with people writing things down. That's what I want. When we get out of COVID and I can hand you stuff, I'll actually make you these packets and print them out for you. If that day ever comes again. All right. So things I want you to pay attention to here is you have no diameter, so you cannot think 180. So here you're going to have to use the whole circle. The whole circle is 360. So let's pay attention what it wants us to find. It wants us to find JKL, and that's an angle. How do I know it's an angle? Because it has the angle marking here. So I want to find what this angle is here. And how do you do that? Is I can identify its associated arc. This arc belongs to that inscribed angle. So if I find this big, long, red arc, I can find the inscribed angle because it's half. So the math you should be seeing in your head here, and I'm pretty sure everybody can see it, is 360 subtracting those two numbers, 53 and 65. That will get you that long arc there. 360 minus 53 minus 65. This long red arc over half the circle is 242. Now this inscribed angle is not equal, it's half. So your math to get this is 242 divided by 2. So that would be 121. 242 divided by 2. Moving on to number 6. I am making a video, so you can rewatch this and go at a much slower pace if you need to. All right. This might take a little time to look at this one because there's a lot of big chaos going on. Looks almost like a spider web inside of this circle here. All right. So I guess first thing is I'm going to recognize the first thing I need to find out. So I need angle RST. Angle RST is this angle. And I know it's associated with this arc. Okay, something that you do not want to get caught doing, and a lot of students do, is this is not a diameter. None of these are diameters, because diameters go through the middle of the circle. So I cannot use 180 here. So do not get caught doing that. You can only use a diameter in half circles if it goes through the center. And they gave you the center of the circle here so you know. So they wanted you to know that this is not any of these are diameters. So how am I going to find this angle? I will find the arc RT, and if you pay attention, everybody, hopefully you're seeing it, it does give you every single arc here. So that means this long green arc here plus this smaller RT will add up to 360. And I'll take 360 minus 139 minus 64 and minus 75. And I now have the arc that I need. Now this angle is associated with this arc, but remember it's inscribed and it's half. So it's 41. This is the first time you're going to see two angles that share the same arc. Because look at the other angle they want. They want angle RUT. So if you look at angle RUT, that also has the same arc. If inscribed angles have the same arc, they have the same measure, because this angle is also half of 82. All right, I'm going to pause this. All right, so I'm going to show you some when you have to solve for x. I'm not going to solve for x. I'm just going to show you how to set it up. Number 7, pretty straightforward relationship. It gives you the angle, and it gives you its arc that goes with it. Just know the arc is always twice as big. So you have two options. To make them equal, you could cut 158 in half and make it equal to 8x minus 9. So that's an option. You could say 8x minus 9 equals 158 divided by 2. That makes them equal. The other option is to double your inscribed angle and make it equal to its arc. Either one is correct. You just pick whichever one you want. So if you just want to say 158 divided by 2, write that down, make it equal to 8x minus 9, you're good. You do whatever you want. Either one gets a correct answer. All right? So here is the exact same thing. You have an angle, but the angle is a whole number this time. Its arc is where the expression is. So to make these things equal, I double the angle and make it equal to the arc. That's one way. Or you take half of the arc. Whatever you do, just know that these two things are not equal. You have to double one or take half the other. Just never make them equal. 67 is not equal to 4x plus 58. That's when it's central. Inscribed angles are never equal. All right. Okay, so here is another problem talking about a diameter. So everybody should see their diameter and know it creates a half circle. So take a look at this angle here. Here's our angle with 13x minus 1. Go to its endpoints. Its endpoint is W and Y. So its arc is out here. So that means this angle is half of this arc. So this arc's 180. Okay? So you can say, you can take half of the arc. So that is a right angle. Any way you look at it, this has to be a right angle because its endmarks endpoints are at the diameter. So anytime you have a diameter and you have an angle that hits endpoints at the diameter, this is a 90-degree angle. So I made this equal to 90 in this equation. This is the correct equation. Every time your angle has endpoints on a diameter. Okay, so this is not a diameter. So I'm not using this as a right angle. It went ahead and gave us 114. So how can we do this? We can do this in a number of ways. I can just say this is the angle with 7x plus 6, and its arc is out here. This is half of that. All right. The problem is it's going to be tough to find this piece. Let me show you how we can start. So we know this much is 78. We can find this because that big red arc does go with 114. So that angle is inscribed. That means to find this red arc, we have to double 114. So this one out here is 228. Now, if I take 360, subtract 228, subtract 78, I now have that blue arc that we need is 58. So once again, these two things are not equal. You can double the angle and make it equal to its arc, or take the angle and make it equal to half of the arc. You have to double the angle or take half the arc. There's your two equations. So that puzzle was kind of tough. Just know, the first thing you want to try is figure out what the arc is and figure out what the angle associated with it is. So I found that 58, and then I could start creating the equation. Number 11. All right, this is the same exact thing. but it's not a triangle. See, there was a triangle in here, but this is the same thing without it being a triangle. So I'm still looking for this. I'm still looking for AC because this angle is the inscribed angle. It's associated with that. Well, I hope you see that you have a 162 and a 92. If you take that away from 360, you will have the blue arc that I highlighted. 92 minus 162. So I took 360 and subtracted these two, and I get 106. Now, I'm ready to set up one of two equations. I'm going to once again double the angle. Or take half of the arc. They're never equal if they're inscribed. I think one last one with more of a kind of a word problem. It's the same thing, but I just want to make sure you guys know how to label this correctly. If FGH is 6x plus 21, where am I going to put that 6x plus 21? Looks like FGH is right here. It's that angle. So my 6x plus 21 is going to go in that little big gap right there. If FJH is 17x minus 28, FJH, that is its associated arc. So this is a pretty complex equation. Find x. So here's the first time that you have an expression in both spots, but that does not change the process. Multiply the angle by 2 and then make it equal to the arc, or take the angle and make it equal to half the arc. Still the same process, it's just a little more complex.